associated with the electrons. So therefore, that maximum kinetic energy associated with the electron at a particular potential VO is given by E into V naught. That is E into V naught. That is K max. So already, if you go through the electrostatics and second chapter, that is electrostatic potential, in that you are going to study how to calculate a potential due to a single charge. Okay, and this expression is nothing but kinetic energy due to a single charge when it is subjected for some particular potential. So this is the maximum kinetic energy with which electrons get repelled, corresponding to the potential is VO. Therefore, K max is equal to E into VO. Now, further, here while studying, I have used intensity I1. Instead of using intensity of I1, now I am going to increase the intensity of the light. Say I will use I2 and I3. Remember, if I replace I1 source of light by I2 and I3, what I am observing? As the intensity of the radiation you increase, you will find that the saturation current will have some higher values. Very simple. See, saturation current for I1 is here, saturation current for I2 is here, for I3 is here. See, values are becoming more. Yeah, I1. For this I1, saturation current was here, but for I2 and I3, the saturation currents will have some higher values. Clearly, one point we can conclude here: photoelectric current is dependent on what? Intensity. Once again, it is proving. Okay. Next. But another one common observation is there. Though I am increasing intensity I1 from I1 and I am taking higher intensity I2 and I3, but stopping potential same as it for I1. So it means stopping potential does not depend upon the intensity of the incident radiation. Remember, this stopping potential is mainly depends upon the nature of the emitter plate as well as frequency of the incident radiation. While studying I1, we have fixed the frequency, hence we are getting only one stopping potential. If I change the frequency, I am going to get different stopping potentials. Is it clear? So this is about the effect of potential on photoelectric current. Next. After studying effect of potential on photoelectric current, now we shall switch on to the next concept, that is I hope that all of you are taking this graphical diagrams. Please make a note of this, and next I am going to discuss effect of frequency. Effect of frequency. Effect of frequency. Effect of frequency. On photoelectric current. Next study, third study, that is effect of frequency on photoelectric current. For this, first I am going to put the graph. Okay. What is this negative x dash? So that is x dash. 6 stopping potential. Collector plate potential. See, the next concept is effect of frequency on photoelectric current. So for this, to study the effect of potential on the effect of frequency on photoelectric current, so go through the previous experimental setup which I was explained in my previous class. See, I am going to use a source of light having a fixed intensity. Remember, fixed intensity of the light I am going to fix. A fixed intensity of the light source I corresponding to the different color. It means a source of 100 watt of blue color, a source of 100 watt of yellow color, a source of 100 watt of light source. Source means light source. Blue, yellow, say some red color. It means it has frequency nu1, it has frequency nu2, it has frequency nu3, you think. So now 100 watt, 100 watt, 100. This is simply, generally I am telling you. 100 watt, 100 watt, 100 watt. Its meaning is what? Intensity remains fixed. Intensity is fixed here, but frequency is changing. And even potential, even the collector plate potential is also fixed here, collector plate potential initially. Now, when I incident a source of light having the fixed intensity I, having the frequency nu1, nu2 and nu3, if I incident one by one I will do. I can't simultaneously, I am not doing here. Initially nu1, then nu2 as well as nu3, and intensity is I. So as I illuminate a radiation of fixed intensity I corresponding to the frequency nu1, then I am going to establish a relation between stopping potential as well as frequency of the radiation. So how I am going to explain? Just I have plotted the graph here. So this graph will give the conclusion for study of effect of frequency on photoelectric current. So what is the conclusion? The first conclusion is, from the graph we can clearly get information here that for an intensity of the radiation I corresponding to the frequency nu1, I have a stopping potential minus VO1. VO means stopping potential corresponding to the frequency nu1. And for the same intensity of frequency nu2, I have a stopping potential minus VO2. For the frequency of incident radiation nu3 of same intensity, I have a stopping potential, that is VO3. It means the first conclusion I am going to do, or the first conclusion what I am going to express here is, the stopping potential is different for different frequency of incident radiation. The first conclusion is what? The stopping potential is different for different frequency of incident radiation. So what is that? Stopping potential is different for different frequency of radiations. First point. Obviously, look at graph. Second conclusion, for a frequency nu1, obviously here nu1 is less than nu2 less than nu3. It means nu3 is more than nu2 and nu1. Second conclusion, more the frequency, more will be the negative or more will be the stopping potential. More the frequency of radiation. So as the frequency increases, the stopping potential also increases in general. of saying this, second point, as a frequency increases, as a frequency increases, as the frequency increases, the stopping potential also increases. It means stopping potential is directly proportional to the frequency. Stopping potential also increases. They are linearly dependent on one another. The third conclusion, the stopping potential is independent of intensity of the incident radiation. Clearly you can look at this. Nu1, Nu2, Nu3, but intensity is I. And remember, for a particular intensity I, we have that stopping potential for due to the variation of frequency, we have stopping potential here. Remember, stopping potential is independent of intensity of the incidental radiation. So though I am varying stopping potential, but so I am having same intensity is not dependent on stopping potential here. Okay, next. After this conclusion, so now I am going to study the relation between or graphical conclusion or some experimental conclusion between this frequency as well as stopping potential. For that, second one is effect of frequency of photoelectric current. Under this only, I am going to study relation, or that is graphical thing. This the relation between stopping potential variation of stopping potential, variation of stopping potential with the frequency. Consider two metal surfaces here. Metal surface in the sense what? Are two photosensitive material plates. Consider two photosensitive material plates, say metal A and metal B. Metal A and metal B. Now I am going to plot a graph between the frequency and stopping potential for metal A and metal B. So what is that graph? I am going to plot here. Just go through this graph. Frequency, here it is, stopping potential. Say this is for metal A. This is Nu1. So frequency, okay, right here, okay, Nu1. This is Nu2. Stop. See, for two metal plates A and B, the relation between the stopping potential or variation of stopping potential with respect to the frequency I have given in this simple graph. See, once if you look at this graph, you are finding that this stopping potential is less the stopping potential is having smaller values. The stopping potential is increasing as the frequency of the radiation is increases. Okay, stopping potential is increases. Stopping potential is increases as the frequency of the radiation increases. Next conclusion: for every metal surface, there exists a certain particular value of frequency, and that frequency only there is an emission of electron will be takes place. Suppose if I illuminate a radiation lesser than that particular frequency, there is no emission of electrons takes place. There is no emission of electrons takes place, hence there is no photoelectric effect. So clearly here, if I plot a graph between stopping potential and frequency, I am observing that the stopping potential and frequency are linearly varying here. As in more will be the stopping, and also stopping potential is zero at a particular, that is a frequency known as threshold frequency. Nu1 is the threshold frequency for metal plate A. Metal plate A. This is for metal plate B. The stopping potential is zero for metal plate A corresponding to a particular frequency Nu1, and stopping potential is zero corresponding to the metal plate B for a frequency Nu2. It means for every metal plate there is a particular frequency, and for every particular frequency it has a particular stopping potential. And remember, as the frequency increases, the stopping potential is also increases. And remember, for a particular potential for a given metallic surface, there will be an emission of electron takes place, and that frequency is Nu1. If I use a Nu1 radiation, say for example Nu1 corresponds to visible UV. Suppose if I use frequency lesser than this, there is no photoelectric emission. So what we call that as, in the previous class only I told you about, that is called as threshold frequency. Threshold frequency. What is threshold frequency? It is the minimum frequency for which emission of electrons takes place. So thereby we can observe the phenomenon of photoelectric effect.